Example of rule of permutation. A permutation is an arrangement of things in a certain order. If no letter can be used more than once, then there are 6 permutations of the first 3 letters of the alphabets. The first 3 letters are A, B, C. So there are 6 permutations: A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. There are 3 choices for the first letter. If any one of the letter is selected over here, 2 choices are left for the second letter, and again there is 1 choice for the third letter. So the product of these 3 choices, 3 multiplied by 2 multiplied by 1, is equal to 3 factorial, which is equal to 6. Finding permutations. If no letter can be used more than once, there are 60 permutations or orders of the first 5 letters of the alphabets when taken 3 at a time. The first 5 letters of the alphabets are A, B, C, D, and E. So taking 3 at a time out of 5 letters, we can make 60 permutations. The first letter can be chosen in 5 ways. The first letter can be selected in 5 ways, and there are 5 choices for the first letter, 4 choices for the second letter, and 3 choices are left for the third letter. So we can multiply 5, 4, and 3. The product of 5 into 4 into 3 is 60. So there are 60 permutations. Using a tree diagram, the 60 permutations can be formed by, let's suppose in the first place we select A, the letter A is selected. Then in the second place, B, C, D, E can be selected. There are 4 choices. In the first place, there are 5 choices. A, B, C, D, E, any one of the letter can be selected. If A is selected in the first place, then 4 choices B, C, D, E are left for the second letter. And if any one of these are selected in the second letter, in the second place, then there are 3 choices left in the third place. For example, if A is selected in the first place, B is selected in the second place, then C, D, E are left for the third place. Any one of the letter can be selected in the third place. So we can make arrangements like A, B, C, then A, B, D, A, B, E. You can make with C, if A is selected in the first place, and out of 4 choices, if C is selected on the second place, so the 3 choices with A and C for the third place to fill are with A and C, B and D, E. The 60 permutations are in the next slide. These are the 60 permutations which can be made taking 3 at a time of the first 5 letters A, B, C, D, and E. Permutations and combination. Permutations are the groups which can be made from a given number of objects by taking together some or all of the objects at a time with regard to the order of the objects, whereas in combinations, order is not important. When different orderings of the same items are counted separately, we have a permutation problem. But when different orderings of the same items are not counted separately, we have a combination problem. Among these 60 permutations, you can see ABC, ACB, BAC, BCA, CAB and CBA. These are 6 permutations, but these 6 permutations are all the same combination because ABC 3 letters are ordered in different, they are arranged in different order. ABC, ACB, BAC, BCA and CAB and CBA. In combinations, order is not important, but in permutations, order is important. So ABC is different from ACB for permutations, but ABC and ACB are same combination. These 6 are same combinations. Similarly, these 6 permutations are same combination. Similarly, these 6 permutations are same combinations, and so on, so on. Permutation rules. Permutation use the entire group and order matters, whereas combination use parts of the group and the order does not matter. Permutation rule number 1 and permutation rule number 2 are for 2 different conditions. If there are n distinct objects and we have to select r at a time, then the formula is npr equal to n factorial over n minus r factorial. Out of n distinct objects, we have to select r objects at a time. And in the second permutation rule, if there are n objects, r1 objects are identical, r2 objects are identical, and up till so on rp objects are identical, then the formula for permutations is n factorial over r1 factorial into r2 factorial, so on rp factorial, where r1 plus r2 plus up till so on plus rp is equal to n. Use this formula when the item probabilities are all different, and use this formula of permutation when some of the item probabilities are alike, they are same. Distinguishable permutations. If there are n1 of one type of objects and n2 of another type, and if there are total n objects, then there are n factorial over n1 factorial into n2 factorial. Distinguishable ways of arranging them. Distinguishable permutations. Example: letter permutations. In how many ways can you arrange the letters in the word Mississippi? In the word Mississippi, there are 11 letters and one of first kind, number of times the letter S repeated, and 2 of second kind, 2, the number of P's, and 3 is 4, the number of I's, and n4 is equal to 1, the number of n's. So using the formula, we get 11 factorial over 4 factorial into 2 factorial into 4 factorial into 1 factorial, which is equal to 34650. So there are 34650 possible ways of arranging the word Mississippi. Another example is, how many permutations of the letters can be made from the word statistics? In the word statistics, there are 10 letters, and 1 is equal to 3, the number of times the letter S is repeated, and 2 is equal to 3, the number of times the letter T is repeated, and 3 is equal to 2, the number of times the letter I is repeated, n4 is equal to 1, the number of times the letter A is repeated, and n5 equal to 1, the number of times the letter C is repeated. So using the formula, we divide 10 factorial by 3 factorial into 3 factorial into 2 factorial into 1 factorial into 1 factorial. Simplifying this expression, we get 50400. The number of permutations of the letters that can be made from the word statistics are 50400. Another example of finding permutations. Jim has 6 different books. Find the number of orders in which the 6 books can be arranged on a shelf. There are 6 books and we have to arrange 6 books on a shelf. The number of possible ways are 6 factorial, which is equal to the product of our 6 whole numbers. 6 into 5 into 4 into 3 into 2 into 1 is equal to 720. There are 720 permutations. This means there are 720 orders in which the 6 books can be arranged on a shelf. Another example of finding permutations. There are 7 soup cans in the pantry. Find the number of orders in which all 7 soup cans can be arranged on a shelf. We are taking all the 7 cans for arrangement, so we use 7 factorial, which is the product of our 7 natural numbers, and is equal to 5040. So there are 5040 orders in which we can arrange 7 soup cans. Another example of finding permutations. If the shelf has room for only 3 of the books, find the number of ways 3 of the 6 books can be arranged. In the previous example, there were 6 books and we have to arrange all the 6 books at a time, and we found the number of permutations by using 6 factorial. But on this shelf, if there is a place for only 3 books, so we take 3 books out of 6 books. We use 6p3, which is equal to 6 factorial over 6 minus 3 factorial. Simplifying this expression, we are left with 6 into 5 into 4, which is equal to 120. The books are arranged 3 at a time is equal to 120 possible ways. So there are 120 permutations, and this means that 3 of the 6 books can be arranged in 120 ways. Here we take 3 books out of 6 books. In this example, there are 7 soup cans in the pantry. If the shelf has only enough room for 4 cans, find the number of ways 4 of the 7 cans can be arranged. In the previous example, we take 7 cans at a time, so we used over there 7 factorial, but here we can select 4 out of 7, 7p4 number of permutations equal to 7 factorial over 7 minus 4 factorial, which is equal to 7 into 6 into 5 into 4. Simplifying this expression, the number of arrangements are 840. From 7 cans, taking 4 at a time, there are 840 permutations. This means that the 7 cans can be arranged in the 4 spaces in 840 ways.